clone of a Xiaomi M365, but actually there's very little difference on the outside. You can't really tell. It has a broken mud flap in the back, but the guy who had it before made it so that the light still works. The issue is it just didn't go, he said, and yeah, it could be a few things, you know. So what I've already had a look at though is when you do plug the cable in to charge it, which kind of puts in, you know, power, it switches on and the wheel does go as it should do. So, and I've already put a voltage meter on the battery terminal on the charge port, and it shows something like 22 volts. So there's an issue with the battery. That's what I can deduce so far. So we're going to go and have a look at it, take it to pieces, fix it, charge it, just have a look, see what's in it. This is, if you're wondering, can you see that? The XCT V385, so otherwise known as the XCT85 scooter. It's the same, honestly. It feels and looks the same as the M365, and of course they pretty much just share the same parts bin, honestly. The whole thing's the same. The good thing is though, this one has the equivalent of the Pro screen. So it tells you how fast you're going. I think it will almost certainly have Hall sensors on this too, but not necessarily, but it probably does. So look, as you can see, it doesn't turn on. You can try turning it on, nothing happens. Bell works fine, the throttle works good, brakes work good, the rest of it is fine. It has, I don't think they're standard because the back tyre is in reverse. It has actually got airless tyres, which I'm a fan of. They do make a big difference in how it feels mentally and physically to ride. So physically a bit crapper, quite a bit crapper, but mentally it's amazing because you can ride it without thinking you're going to get a flat tyre, which would put a big downer on your day wherever you're going. And a lot of students and people that use them for work, you know, they would be using them as a commuting tool, and so it needs to work as a tool which is reliably, which is not really the way that electric scooters work. They aren't very reliable generally, which is kind of why I try and repair them and do it on camera so that people can learn. With my other videos, you know, I always get comments from people saying thank you very much, which I like. I really like it when people say thanks, or they learnt something from the videos, or it helped them figure something out, you know, or if I tell them what screwdriver to use. That's pretty cool. I like that. Not everyone's a bit of a geek, you know, not everyone's a bit of a fan of doing this stuff, tinkering. So rather than using the workshop and the or the office where I normally do these things, I decided to do it outside on the veranda because it's a nice day and it's a bit easier to do that. So we'll put that on the table, turn it upside down, and I've had a look. Instead of having a series of Torx T10 screws underneath, it's just a Phillips posi drive screwdriver. So we'll just undo all the screws, pull it off, have a look, we'll talk about it, and we'll get into it and fix it and see what's wrong with it. So I'll make more of these videos and I'll talk about different things on them, electric scooters, and one of the next videos I'm going to do is talk about how heat affects electric scooters, which is terribly, actually. And so if you think I'm not doing a very good job of something in the way that I record, or if I talk too fast or something, just let me know and I'll eventually make it so that my videos are just, you know, hopefully quite an easy watch for people. And I'll just put this over here without smashing everything and breaking everything. Right. So, oh, actually, what I can do with my stand, because it's awesome, is put it up like that. There we go. Right, I'm ready. Boom, here we go. So this looks very different to a regular Xiaomi. So this controller here is very different, that's for sure. And the wiring looks alright, you know, it's got alright connectors. It all looks neat-ish. It's all done alright. Battery seems alright. I'm going to stick in multimeter, see what voltage we get, and just see what's happening. I'll just set you up there. Apparently it's showing 32 volts now. Can you see that? 32 volts. Something's not right. We'll go into it. That's a very useful tip, I reckon. If you're going to buy a scooter and you want to make sure the battery's in good condition or it holds charge, or if you're buying a scooter and you're not sure what the issue is, you're buying it broken and you're going to give it a go at fixing it, if you want to make sure it's not the battery that's broken, or at least the battery's there and that it's got a correct amount of charge in it, stick a multimeter in there, see what you get. The middle pin is the live pin. The outer connection in there is the negative, so you just need to remember that. Yeah, Torx bits in this, okay, no worries, I can do that. Not a problem. Cool. Get the screws out. Battery should come out, as it does. Bish bash bosh. There we go. I'll get stuck into that, see what's going on. I can already see that it's got 18 650 battery cells in it. 10 in series, 3 parallel, which is about right. See what's going on. I wouldn't be surprised if there's a blown battery. You know, when they cover batteries up like this and they cover them in this plastic heat shrink stuff to protect them, really not great for the health of the batteries, really, because it sort of encapsulates the heat, and the heat sort of you know, gets stored in and around all the cells. And again, you know, they haven't really put any cooling on it. They haven't put any heat sinks or fans or any. Obviously there's no water cooling going on, so the batteries just get hot, and they get hot and stay hot and get hotter. Which sucks. Let's try and get into it. Oh, obviously I'm on the back veranda. I don't have all my tools in arm's length, but what I'm doing is just looking. I'm going to take off all this, and we will have a look for any loose connections, any burnt bits, anything that looks odd, and then I'll go through every battery and test. Straight away, I mean, I probably just pulled that off, but there's a wire here that goes through here and it pokes out there, and that's not soldered to anything, so that would have gone there, but that would just be for balancing. That wouldn't be actually for charging. That would just be for the balancing part of the charging, you know, so not really. Oh, and I've done it again, so I'm pretty sure I'm just breaking wires here. Cool. But again, oh, can we do a third one? Ah, Jesus. I've played with batteries a lot, you know, and I can tell you for sure they're really dangerous and they go wrong, so always think about, is it going to go wrong? Is there going to be a spark or a fire? Where are you doing it? So if you're going to do this, don't just do it in your bedroom and think you can throw a pot of water on it and that'll fix the fire. Have a think, do a bit of research, speak to any electrician you've got in your family or your friends, and you'll probably be fine. But you've just got to be safe. The option's not there. It's a non-negotiable. If you're going to play around with batteries, even for a bit of fun, you know, it's got to be done safely. You don't have a choice. All the connections look fine. Obviously, I have to solder on these little connections here on these dodgy wires. I don't see any issues with the connections, so it is maybe going to be. I mean, I can't see all these connections, so who knows? But it might be that there's just a broken cell. You know, who knows? But we'll get to that when we do. Anyway, I'll strip all this down and I'll come back. So what I'll do first is I'll show you the issue. So here is the light, it's green currently, and I can't show you. Basically, when it was plugged in before, it would go from green to red, saying it was charging, and then after literally 3 seconds, it would realise there's an issue, and it can't charge, and it would flash red and green really fast. So it'd be alerting you there's an issue. So a 36 volt battery, when it's dead, should be, well, instantly. I've just realised I can feel that battery's really hot, so there's an issue. We'll get into that. Yeah, so it should be between 30 and 42. When they're fully charged, the whole battery will be 42 volts. So, can you see that? You can't really see that, can you? But what I'll do is I'll put this here, like that. Can you see that? So that's not the best lighting. I'll have to move you actually. We need a plug. Plug it over there. Yeah, there we go. That's something. So if I put that there, is that any better? Should be. Yeah, that's alright. Cool. So we'll check the voltage on the battery and we'll see what it is. So there you go, you can see that. Always do negative first. Put that on 200. I set it on 20. I wondered why it came up with 1, but it's because I'm checking over 20 volts. So 200 is the correct one. So it's showing 25 volts. Yeah, 25. I don't know why it keeps flickering around like that, but that's not normal. But 24 volts, 24, 25, something. That's for sure. So what we'll do, we'll check every single cell, every single one, see what's going on. They should all be between 3 and 4.2 volts. They're probably all going to be different or somewhere different because they'll have worn down at different rates probably, but we'll check them. So 3.8 something, that's alright. One below, 3.8 something, that's fine. What's that one? This next one across, 3.8 something. Next one of that, 3.8 something. These ones are good, nice and consistent. 3.7, 3.8. Yeah, that's fine. This next one, what's going on? Yeah, 3.8 again. Oh, these are looking bloody good. Oh. 0. What? Well, that's buggered. Right, I think we might find one problem. 0.67. So this cell is buggered. This one. Is it warm? No, it's fine. But that's not right. That's a broken cell. Which is annoying because you look at all of them, they all look nice, there's no water damage, it's fine, but one of them has just decided to stop working. That's the way it goes sometimes. That sucks, but that's how batteries work. So now it's saying 0.8. I'll keep going. 3.8. 3.8. Yeah, so the only one that was wrong was actually this one here, and I imagine what's gone on is because I do notice the nickel plating which goes across there has actually broken. So I imagine that's stopped that battery charging up, and then that's just ultimately died. So that needs replacing. All the rest is fine. So what we'll do is we'll replace that cell and reattach these balance things, check the voltage, charge it, put it in the scooter, see if the scooter works. That's what we'll do. Yeah, that's what we'll do. Right, give that a go. Yeah, that's feeling warm, and yeah, it's as if the other connector, the nickel plating as it's sat across the top, has split, and as I've been tinkering around with it, I can tell that I've been pushing the nickel plating into the top of the battery, which is kind of, when it's being touched, it's trying to rapid charge it very quickly, and that's causing it to heat up. But of course, it's a dead cell, so it's not going to charge up. So it just comes out as heat. Instead of it just storing that energy, it comes out as something, which is heat. Because the energy has to go somewhere. So we'll just double check that now. It's taken out. That's just a bad cell. It's a GX 18650 is what it is. 2000 milliamp hours, and I imagine it says 19D, which I'm going to guess is 19 amps it can put out. But I could be wrong. We'll check it. It is, okay, 0.62, 0.64, 65, 66, 64, 63, 62. It's buggered. Anyway, it's definitely buggered. So I'll go find another cell for that. Here we go, new battery. This is from a drill battery, and it is a Samsung INR 18650 20Q. So I think it's a 20 amp battery. It's currently charged to 4.2 volts, so it's full, and that's the buggered one. So we'll put that in there, make sure all the connections are fine, and solder up these, and then we'll retest the voltage and see if it's gone up from I don't know, was it 24, 25? But then on the scooter we checked it and it was like 30, I don't know. So we'll check it's fine, we'll make sure it's all working alright, and let's get on with it. So what I was going to show you as well is, this is my soldering iron that I use for everything, literally everything. It's somewhat amazing. It's a Dremel, it's called a Versatip, I think, and it's not expensive. I think it was like £37 or something, and it comes with different tips. So you can use this here as just a hole, so it blows hot air, really hot, 1300 degrees, and you use these camping tins to fill it up, and you literally just push it in like that, and then it sprays at the end. When it's full, it just sprays a little bit, and then you take it off and it's full, and that probably give you realistically like 30-40 minutes of use on full. But you can do pretty much all soldering in the first half of the range, so on the lowest setting, on the middle. But sometimes when you're trying not to have much heat creep on a chipboard, you just put it on full so you can quickly get heat into the solder, and then it doesn't really seep into anything else. So I recommend this. Really good. For example, when I just took this, it also has this sort of plastic cutting tool thing on the end here that you can take off as one of the pieces, and I use it for just, you know, nipping into the plastic frames so I can remove a cell or, you know, repair them. And I actually use that for all sorts of things, like repairing the car bumper, for example. All sorts of stuff. Really good tool. Right, here we go. Let's turn that down a bit. No, actually, what I'll do, I'll just fill it up. Just and if you're having an issue with getting the solder to stick to the battery tips, then just scratch this the surface of the battery on the ends, on the terminals, and you can also get solder cream, solder paste, whatever you call it, and that works really well at just making sure things bond together like solder. Really good stuff. I recommend it. It's really good. And this is a gift from my brother. It's a tool to take the ends of wires off the stripping. I don't really call it stripping tool. I used to always use, you know, like pliers, like the ends of pliers here, and just pull the end of the wires off. But these are actually just awesome. And just put the wire in the end, squeeze it, pull the end of the wire off. Bada bing, bada boom. Works great. Right, we're good. That's all done. Let's check the voltage, see what's going on. I mean, I think it should be fine. Hopefully, we're going to see 30, 40 volts, something. $40 volts, 42 volts. That's saying 50 volts. That's not right. Ha! Let's have a look. What do we got? No, we got 41. 41, 42 volts. She's good. 40, 41. 40 volts. So she should be fine. Honestly, she should be fixed. Now, a little trick, what I like to do is spray silicone spray all over my batteries. Just not the stuff you put, not tire shine, not for your car wheels, not that stuff, but silicone spray, which is otherwise known as PTFE spray. So you can spray it on things electrical, like literally directly onto a chipboard, and I wouldn't do it on a computer, but I reckon you technically could. It just keeps things waterproof, which is a great thing. PTFE spray or silicone spray, it's only $5 or $10, depends where you are, and it's brilliant stuff. Really good as a lubricant for lots of things, but also really good for just keeping things waterproof. It's really good, and it doesn't leave a residue, so when you spray it and leave it to dry, you can't even really tell it's on, but it keeps things waterproof. It's brilliant. So if you do get any water or condensation or moisture seeping into your batteries, like if you're in England, a lot of people ride electric scooters in London, then that will definitely help you, even though they are quite well wrapped up. But water finds a way. It really does. So it's a bit annoying, but it does. So let's see what happens when you... Oh, I can't charge it, can I? Right. I'll put this next to the scooter. I'll plug the wires in, and I'll plug it in charge and just see what happens. It should hopefully just recognise it, charge it, and be fine. The scooter should turn on, should just work. That's what I'm thinking. Right, let's give it a go. So, as you can see, the charger light is green. That's a bit difficult to see, but you can see it. Plug it in, it should go red and then stay red instead of flashing. You don't want it to flash, so it's red. Or looks a bit orange, but it's definitely red. And I think it's fine, it's charging. That's probably going to spend some time balancing as opposed to kind of charging. It's probably just balancing, which is alright. And I'll take that out, so like that. I'll plug in this and we'll just turn the scooter on, see if it actually works. It just works, you know. Put that in. Press the button. Does it work? We press it once. Does it? Or do you keep your finger on it? Oh, hello. She works. And just use the throttle. Cool. Now she works. So really, really important. I'm not going to ride this. I'm just going to bolt it all back together and make sure the charger has time to balance the batteries before I do anything, because that's quite important. Not the most important thing in the world if it's just the once or twice, but if I'm hoping to put these all back in here and it actually work for any length of time, that's what you want to do. And I will also wrap up these battery cells a bit, because they're not really in very well, and they're quite wobbly inside the frame there, so I'll seal that up. Here we go, let's give it a quick go. Of course it rained a little bit, but not much, and it stopped raining, so I'll give it a quick go. Right, here we go. Turn it on. There we go. I'm just rolling. Actually, this is downhill. That's not fair. Ooh. Ooh. There we go. Working lovely. There you go. Can you see that? 22. 25 kilometers per hour. Hey, look at that. Beautiful. Hey, she's doing all right. Yeah, I'll go back now. I don't like riding this in the wet. There you go. And for those of you that want to know, this is the spray that I use. It's silicone spray lubricant. That's the one. So I just used it as well to spray on the throttle, just in and around all the cracks, just like soak it. And of course it's fine with all the electric stuff, but it just makes everything work really well. So recommend that.